The last thing I'd like to talk to you about in analysis is colour. Colour is actually a very big business industry. 20, 30 years ago, there was no colour measurement. Possibly when you were at school, you were told stories about how the eye sees colour, as you have these red, green and blue cones in your eyes that see colour. Colour is actually a lot more complicated than anybody ever realized. The colour measuring instrument that we use is called the eye. The eye has got all sorts of interesting things inside it. There is a... oh, that's not what I wanted. I wanted that. There is a retina. The retina is the thing that sees. Most of the retina, and the retina stretches to about here, most of the retina sees in black and white. The only part of the retina that sees in colour is here. That little thing there, which is in the optical axis of the eye, that little spot there sees in colour. It's called the fovea centralis, which means the central hole, really. The optic nerve comes out of the brain and goes into the back of the retina. The interesting thing about the optic nerve is it's actually brain matter. The retina is actually brain matter. So the retina does processing. It's a pre-processor. It's not just a dumb sensor that sees colour. It's a pre-processor, and it decides what type of colour it will see. Inside most of the retina, you have rods, which see in black and white, and then you have three different colours of cone: red, blue and green. The colour cones only exist, or mostly only exist, in the fovea centralis. The bits at the front, they're purely to focus the image. So you have the pupil and the lens and the iris. They're just to focus the image and to limit the amount of light coming through. This is our colour sensor. An object looks a certain colour according to three different things. Firstly, the light source. Different light sources will make different objects look different colours. So that if you look at something underneath sunlight, it might look blue. But if you look at it under fluorescent light, it might look greener. And if you look at it under incandescent light, it might look a different colour again. Similarly, you might have two objects which look the same colour under sunlight, but under fluorescent light, they look quite different. And under incandescent light, they look different again. So different objects will appear different colour according to the light source. The second thing that's important to an object's colour is the surface. If an object has a shiny surface, then you get what's called specular reflections. You get highlights off the object. If you get specular reflection, the object looks lighter because it looks brighter. Whereas if an object is a matte colour, the object looks duller and it looks a darker colour. So the surface is the second important thing. The other thing that's important about colour is which colours are absorbed by the surface. If the object absorbs everything apart from red, red is reflected off it, and we say, oh look, that object looks red. So the object's ability to absorb colour is actually the object's colour. The third thing which governs what colour we see an object is our eye and our brain. Now here's where it all goes badly wrong. Firstly, the retina, the cells in the retina are actually modified pressure sensors. So they respond to pressure. The eyeball is kept pressurized to keep it inflated. The pressure in the eyeball varies according to things like how tired we are. So as the pressure inside the eyeball changes, things look slightly different colors. That's the first problem. The second problem is that we will see different colours according to our mood. If we get, for instance, very, very angry, then the brain sends out signals, all right, I'm very angry. Supposing you're in a fight, you've just been attacked by a lion. The brain sends out signals, okay, I want you to give me just the bare minimum information that's coming along. I want to see things like movement, and I want to see red. Red is an important colour. Red indicates blood. It's either my blood or the lion's blood, but red is a colour I want to see. Nothing else is important. I don't care whether the grass is green or the leaves are green. I just assume that's going on. Mostly I want you to give me information about movement right now, because we're in a fight. I want you just to trim down the important stuff so that I've got a chance to think. So when we get angry or upset, we tend to see things redder. In fact, we've even got the saying, he was seeing red. So our mood alters the colours we see. And the eye tricks us all of the time. What I'd like you to do is look at these two orange dots and tell me which is the lighter coloured orange dot. Is it the top one or the bottom one? Well, I'm actually surprised that you are seeing it. You are right. They are both the same colour. Both of those dots are the same colour. The bottom one appears lighter because the eye is telling us, yeah, that's a lighter dot. It's not. It's exactly the same colour. Now, second question. The grey square surrounding the orange dot, which is the darker grey square? The top one or the bottom one? You won't believe it, but both of those grey squares are the same colour. Now, I didn't believe it myself. I had to take it to a drawing program and test it, but both of those grey squares are the same colour. And the eye, once again, is tricking us. So we have big problems. If we want to make a colour sensor, we have big problems with the fact that the eye is not a very consistent thing to measure with. See, if I want to measure the length of a table, I pull out a ruler, and that ruler is a thing that allows me to compare the table to something else. But if I want to measure the colour of something, what do I compare it with? I don't have a good sort of sample from the eye, because what colour the eye is telling me varies with things like the context. So the eye will tell me, oh yeah, that grey is lighter than the other grey, when it's completely wrong. They're both the same grey. So I have big problems with the eye. Another thing the eye does is the eye really, really, really wants to see red. To the extent that when the eye sees something red, it kind of disables our ability to see blue and green. So if there's lots of red around, the eye sees it a lot. Compounded with these problems is the fact that when we see colours, we use what's called the RGB spectrum, red, green and blue. It's what's called additive colour mixing. But when we're mixing up paints to colour something, we use CMYK, cyan, magenta, yellow and black. So if I need to make something a certain colour of green, I look at it using the RGB spectrum, but I need to paint it using the CMYK spectrum. The way I see it in the RGB spectrum is dependent on my eye, and my eye exaggerates red, because red is important to the eye. Whereas in the CMYK, the yellow is exaggerated. So in order to take what the eye sees and turn it into a paint color, you need to have a very, very sophisticated computer. 20 years ago, creating the right color would take about half a day. Now you can go to Bunnings Warehouse and have it done in about 5 seconds, because a computer, your average home computer, is powerful enough to do the maths. But it's a lot more complicated than just saying how much red, green and blue there is, because you have to take into account there's this amount of red, this amount of green and this amount of blue, but the red goes a long way, so I need to add less red into the color mix, and I need to know precisely at every frequency what to do to add colors. Now you might be thinking to yourself, oh well, color's not important, it's not a big money industry. Actually, color is an enormous money industry. Because if you've got your average sweatshop in Thailand, where they're making dresses and handbags, they're making dresses for maybe 50 cents a piece. But those dresses are selling in New York for $5,000 a piece. And they're making handbags for $2 a piece. And they're selling for $6,000. Now that is a massive profit. They're going to make 10,000 dresses and 10,000 handbags. Every single one of those dresses has to match every single one of those handbags. And because of the huge profits involved, we have to get it right. So in fact, getting colors correct is a massive money maker. And it's only in the last 20 or 30 years that we've really been able to produce 10,000 dresses and 10,000 handbags that match.